Hello, this is Mr. Collier, and today we're solving absolute value equations and inequalities. Okay, so in this first example, we have a absolute value equation, and of course we know absolute value. With absolute value, if the absolute value of negative 3 is positive 3, and the absolute value of 3 is also 3. So we just separate this into two equations: x minus 2 equals 3, or x minus 2 equals negative 3. So we'll separate into two equations and solve each of those. So we have x equals 5 or x equals negative 1. In the next example, very similar, except we have an expression on the other side, but we can do the same thing. We could say x squared minus 3x equals negative 4x plus 6. That's one possibility. Or you could have x squared minus 3x equals negative 4x plus 6. Okay, so solving these independently, we get some quadratics. X squared plus x minus 6 equals 0. So x plus 3 times x minus 2 equals 0. So x equals negative 3 or 2. And in the other equation, we have x squared, and it's going to be plus 4x subtracted. We're going to get minus 7x, and it's going to be negative 6 come to either side is plus 6. So that's x minus 6 times x minus 1 equals 0. So we have x equals 1 and 6. So we have a total of 4 solutions out of that. Okay, in the next example, we have absolute value on both sides of the equation. One thing we can do, because we know, one thing we can do is just square both sides, and it'll get rid of the absolute value. Or we could say, just similar to before, we could say x minus 4 equals 2x plus 3. That's one possibility. Or we could have 3x minus 4 equals negative 2x plus 3. So there's only these two possibilities. You could say the negative this side equals negative this side, but the negatives would cancel and we just get the first one back, right? Or if we said this side was negative and this one was positive, we get the same equation. So there's only really two possibilities, and we can solve them both. So x equals 7, and over here we have 5x equals 1. So x equals 1/5. Okay, for inequalities now, this is less than or equal to 3, so numbers like 2, 1 work, or negative 1, negative 2. So in x plus 1 is going to be any number between negative 3 and 3, and we can solve this inequality. That should be 2, right? And this should be negative 4. Okay, and now this type of thing, we could solve it graphically. Graphically, these are absolute value functions, so they have a V shape. One's centered at 1 and one's at 4. Okay, so we can see it's really just the one intersection point, and we can get equations for both of these lines, right? We could say this line here is y equals x minus 1. It's going to have a y-intercept down at negative 1. And this line here has a y-intercept at, this is going to be a y-intercept at 4 and a slope of negative 1, so y equals negative x plus 4. So you can simply solve the equation x minus 1 equals negative x plus 4, and you'll get that point of intersection. So 2x equals 5, and x equals 5 over 2. Or what you can do in these situations, since we know both the left-hand side and the right-hand side are positive, you can square both sides, and then you get some quadratics. You get x squared minus 2x plus 1 equals x squared minus 8x plus 16. The x squares cancel. You got 6x equals 15, and x equals 5 over 2, so you get the same answer. Okay, this one is a little bit more complicated, and we're going to use our GDC for this one. So so let's type in the function. You could, of course, square both sides and then graph that one, but let's just graph this. So absolute value under math, there it is. So we have x squared minus 5x. Okay, and there's 6. Let's just check my window. My window looks normal. Let's see if... Actually, maybe I'll need negative 10 to 10. Okay, let's see what it looks like. Can I see all the points of intersection? Okay, well, that looks interesting. Maybe does it intersect there? Let's check it out. So let's get the points of intersection. 5. And this one is negative 1, 6. Okay. So it looks like I'll draw this line over here to represent 6. Okay, so let's draw that function. It looks like from the graph actually that it intersects at 2 points right here, so be very careful. It's not 1 point. It goes like that. Okay, so let's find those points of intersection. Second, calc, intersect, and let's get that one first. That's 2, 6. Okay, and the next one I'll go over closer to this point. Do second, calc, intersect, get closer to that point. It's 3, 6. Okay, and if you get the other points in the same way, it's negative 1, 6 and 6, 6. Okay, so where is this function less than 6? It's less than 6 in this section and this section right here. So we can write that as x is between negative 1 and 2, union between 3 and 6. Okay, lastly, I'm going to solve this one graphically without using the calculator. So if the function is just regular, we're going to do the regular function 1 over 2x minus 1 and then do the absolute value of that and see where that's less than 1. So that function is going to have a horizontal asymptote when this denominator is 0, so when x equals half, and it's going to have that's a vertical asymptote. Horizontal asymptote at y equals 0, because this is like x to the power of 0 here, so 0x to the power of 1, and the ratio of the coefficients here is going to be 0. So anyway, we have a horizontal asymptote here, vertical asymptote at x equals half. Okay, the y-intercept, you plug in 0 here, the y-intercept is negative 1. So your function is going to look like this. Okay, and then when you absolute value that function, all these negative parts are going to pop up here. So it's actually going to look like that. Okay, so this is our function that we have right here. We want to see where that is less than 1. So we can solve this here, 1 over 2x minus 1. That's this part here, because the original blue part and red part are the same, so we can solve that equals to 1 to get that point. And solving that equals 1, we have 1 equals 2x minus 1, 2 equals 2x, so x equals 1. So at this point, this is at this point x equals 1, and the y equals 1. And over here, because of the symmetry of the graph, this is negative 1, 1. And we're looking for when this function is less than 1, that would be in this region and in this region. So when x is less than -1, union x is greater than 1 is our solution.